risk assessment. Here is your mission. Now that you have your LCP files created, you're asked to produce projected fire behavior output for these three scenarios. No treatment, but corrected for current conditions, with the completed slopes units in place, and then with the future slopes units in place. You're asked to report on whether the current and future slopes projects are expected to reduce the burn probability, flame length, and average fire size inside and outside of the treatments. You will deliver these findings to the project stakeholders, and they will decide if additional money and time should be devoted to this endeavor. So, no pressure. The first thing that we're going to do is just get a basic understanding of what your computer abilities are. You might not know much about computers, which is totally fine, but one thing that you should know is whether your computer has a lot of capabilities for processing or not very many. The reason that that's important for this lab is that we're going to be running through some computations in a program called FlamMap, and those do take some pretty decent computer requirements. So things like RAM, storage, memory, and processors are all going to be important in making sure that FlamMap runs successfully. And because most of you might not have a lot of control over the type of computer that you have, we will make the outputs available for those that aren't able to complete the runs in FlamMap. But something to keep in mind as you're running these is try and reduce the amount of other things that are going on in the background. A lot of things on your desktop, like these programs that might be running, might be good to remove those, or checking into your computer system abilities and doing what you can to free up some space on your computer. So to begin, we're going to go back to our ARC Fuels tutorial, and we'll be using directions, quite a lot of directions from the ARC Fuels tutorial today. So I'm going to go back to the tutorial. And in my fuel treatment planning scenario, my no treatment alternative that we worked on last time, and under building no treatment alternatives, we're going to continue on with this exercise. So we've already built our LCP file, and now we're going to be using that LCP file to run in FlamMap. So you can either open FlamMap through the Programs folder of ARC Fuels on your C drive, or you can go here to your Wildfire models, select FlamMap, and when doing this, you'll need to locate it, and it's in under your C drive in ARC Fuels, Programs, FlamMap 5, and here's the run file for that. Click Close. And it may open up automatically, or you may need to go back to Wildfire models and then select FlamMap, and it'll open up just like this. So this is the FlamMap program. This is the interface, and this looks just the same as if you were to download FlamMap as an independent program. So the first thing we're going to do is just take a moment to make sure that we have our data organized. Sometimes when you're working on a project, you label things a certain way that makes sense to that part of the project, and then when you're doing something else, you might need to change those names. So to change those names, because it's an LCP file, you can either change them from ARC catalog, or you could actually go to your C drive and change them here without much trouble. So remember, we copied these LCP folders over from lesson 4, and now I'm going to rename 2 of them. So LCP corrected is less meaningful for this part of the project than something like no treatment corrected. And this FMS file, we will work on creating that in the next step. The second thing you want to change is just add a little more detail here. So slopes and then completed 2014, and we will keep slopes target areas the same. Now that that's done, let's go back to FlamMap, and using the guidance from the ARC Fuels tutorial, we will create our first FlamMap run. So double click on No Landscape file and find your No Treatment Corrected file. I'm going to make this a little bigger. So you can see this is the LCP file that I created, and it has all the different layers. And to create fire behavior output, I'm going to double select Run and label this No Treatment. And now a fuel moisture file is something that is a really important piece to any fire behavior modeling. So I'm going to take a moment to explain a little bit about fuel moisture files and where those come from and how you can create them and how to make sure that they're the most accurate. Now, running Fire Family Plus is not a part of this class, and if you are interested in more information, I can provide that to you, but I think it's an important background to understand what kind of output we're going to be getting and where that came from. So, quick side note on Fire Family Plus. It's a program that takes historic weather information and consolidates it into various different forms depending on what you're looking for. So I went to a site where this weather information is available, and I downloaded the weather data for the last 10 years for the Bright Angel RAWS station, or Remote Area Weather Station. And so first I'm going to import that data and select this FW13 file. Now that that's complete, I see that there are no errors, and so I'll click Close, and I'll make sure to select the Bright Angel RAWS station here. So I've got a couple different options. With climatology, you can see average temperatures, precipitation, relative humidity, but I'm mostly interested in the fuel moisture. And so one technique to use to get the fuel moisture is to run a different calculation here. To perform this different calculation, I'm going to go to Weather and Season Reports, and we're looking for percentile weather. And percentile weather is something that we use when we're looking for what the most extreme weather conditions were, and that breaks it down into different categories. And this is useful since if we want to run our fire behavior scenarios for weather that is on the hotter and drier side, then we'll use a higher percentile weather. So we'll click here. And then we have a couple different options here. These are all pieces of what's called the National Fire Danger Rating System, or NFDRS. And although you might not be familiar with the name, I'm sure that all of you have seen the Smokey Bear signs that are around in most forested areas and non-forested areas that show your fire danger for that day. And that's just a measure of what kind of potential fire behavior you would have if a fire were to occur that day, and it influences things like the number of people that are around to fight fires and different planning that might go into effect if a fire were to occur. So we're going to select Burning Index, which is kind of a catch-all. It's a good representation. It's correlated with flame length that we might expect for a fire that day. So now I have my percentile weather. The first thing I come to is that I need to enter a wind direction. And so from my climatology data over here, I was able to look at my wind direction and wind speed and get some kind of an idea on where the winds typically blow from in this area and how fast they typically go. And so I was able to determine that they typically come out of the west. And so then following these directions, I can click Calculate number 1, which populates this table. And then I can click Calculate number 2, which populates this table, and then Done number 3, which populates this table. And so what you get is you have the percentile range. So 98% or 2% of the time it is in this extreme category, and then here's your high category here, 90 to 97 percentile, and moderate and low. And since we're wanting to run our fire for conditions that are potential wildfire conditions, but not necessarily extreme, we're going to use the fuel moistures that are in this high category. Now, if you don't have access to more specific site data like this, then you could get some general information on what low, moderate, and high values you could use for fuel moistures. And you can get that from going to this Scott and Bergen publication, and near the top there's going to be some tables for fuel moisture. So on page 8, you can see that we have a table here for your very low fuel moistures, low, moderate, and high for your 1, 10, and 100 hours. And then you also have estimates for your live woody and live herbaceous. So you could just use these canned fuel moistures, but we'll use ones that are more specific to our site. So notice that very low would be in the extreme category. Low would be in our high fire behavior category, so it's a little bit different there. But just looking at those numbers, you can see how they compare to what Fire Family Plus is producing, and that they are a little bit different. And so we will hopefully get an increased accuracy in our outputs by using these fuel moistures. So back to FlamApp, we're going to click this plus sign, and we're going to create our fuel moisture file. And so we'll go to Fire Family Plus, and it looks like our 1 hour fuel moisture is going to be 4, and I'll just slide this over. Oh, I won't be able to do that. So that's going to be 4. Put that in here. And 10 hour fuel moisture is going to be, we'll say that's 5. Our 100 hour fuel moisture is going to be 8, which is the same. Our herbaceous fuel moisture is going to be 44. And our live woody fuel moisture is going to be 98. And we can click OK. Now that we have done that, we have this file that's been created. So it's a text file, and you can save this file. So go ahead and save it, and save it as NR_high, so North Rim _high, and that tells us that these are the high fire danger rating fuel moistures. And it'll just add this .fms file at the end, and that makes it available for being used as a fuel moisture file. In the future, if you wish to change some of the fuel moistures, for example, an FMO that we work with occasionally has found that one of the fuel models that he works with has a higher fuel moisture than is typically seen with some of the other fuel moisture, so it's not the same. So going back in and adjusting the fuel moisture for one fuel model might have a pretty significant impact on the fire behavior that he's going to be modeling, and where that fire might be expected to go, or how it might be expected to behave. So these are pretty fluid documents you have the ability to change, and by creating it in FlamApp, it pulls out the fuel models that actually exist in your file. So close that out. And so now that you've created that, you can navigate to where that is. So I'm already in my Lesson 5 inputs folder, and your NR high, and add that in there. And so again, based on information that was averaged from Fire Family Plus, we have our average 20-foot wind speed of 6 miles an hour. And from my climatology section, I was able to determine the rough location that the wind typically comes out from. So from 230 degrees, and our wind speed, so miles per hour at 20 feet, is 6 miles per hour. And so go ahead and click Apply. And then we're going to go to the Fire Behavior Outputs tab. Now this number of processors here, it should default to what your computer has available to it. It has to do with the processing speed. So we'll keep that the same. And we're looking for our fire line intensity, rate of spread, flame length, and crown fire activity. And I'm going to select the Scott and Reinhardt crown fire calculation method. These are both just different ways to calculate whether a crown fire is going to occur in an area. And I'm going to click Apply. Now I know about my machine that it does not have the ability to do the next step of this run, this minimum travel time, but I do want to at least get my fire behavior. And so I'm just going to go ahead and launch my fire behavior from here. But first I'm going to show you how to enter your information for minimum travel time. So we're going to have random ignition, so I'm going to click random, and you're going to select 2000, and the resolution of calculation is going to be 90. Again, this is something you don't need to know a lot of detail about, which is just something that we're going on the recommendations of the ArcFuels tutorial. So 90 here, 360 here, leave all these values the same, and we're looking for burn probability and fire size list. Now, I would suggest that if you aren't sure of your computer's capabilities, that you give this a try to launch the MTT, which will also launch your fire behavior output. Before doing that, though, I recommend saving everything that you have open, closing things. So that would mean closing ARC, closing any internet that you have. Chrome takes up a lot of memory. So closing anything that you have open, especially things that you've been working on that need to be saved. And then attempting this launch. And it could take, on a faster computer, it will take 5 minutes. On a slower computer, it could take 20 or maybe even more. So go ahead and give that a try. If I were to attempt this on my current machine, it would just shut it down within about 5 minutes. And so I'm going to go back here. So I haven't clicked. I'm going to actually cancel this page. Oh, it closed it. So, but since I clicked apply, it actually saved the stuff that I'd entered before, and it didn't save my minimum travel time, which is good because I don't want it to run that. So now that everything's set here, I'm going to select Launch FB. And as you can see, that completed really quickly. The reason that minimum travel time takes so long is that you have all these random ignitions, and it's quite intensive. So I'm going to click cancel here, and now I have my output files. So with this no treatment expanded, I'm going to pull this over so I can see the whole area. And then I'm going to set things up for the screen capture that I'm going to be submitting on BBLearn. So to do that, I want to see a couple different things. So I want to be able to see a little bit of the work here that I've been doing so that I can see the uniqueness there. And then, so I just double clicked on no treatment, and I'm going to drag that over here, and I want you to set it up so that we can see that fuel moisture file. So go ahead and click this pencil button, and I'm going to shrink this up a little bit. And so this way we can see the fuel moistures that you entered, some of the inputs that you have, and the names of what you have going on. And I'm going to use my snipping tool and create a new one, and then copy this whole area. And this will be what you save and submit on BBLearn. Now that we have that run completed, before we move on to the next one, we're going to want to make sure that we save these output files so that we can have access to them in ARC. To do this, we need to go to the directions for ARC fuels and look at what we're instructed to do. So as you can see here, this is where it shows the output that was created in the tutorial. So it's near the bottom of the page. And so we're looking for a couple different things. Not all of the output we'll need. So the first one we're going to need is flame length. So we'll go back to Flam Map, and we will right click on flame length and click Save As. And now I'm going to go up to my Lesson 5 folder, and I'm going to make a new folder here. So I'm going to right click and click New, and I'm going to label this folder Outputs. So we're going to put all the outputs in this folder for each of the 3 landscape scale files that we're going to be working with. So we're going to need to make sure that the files that we save here are each distinct. So the no treatment, we're going to label those ones NT and then underscore, and this one's going to be FL for flame length. And it's going to be saving as an ASCII grid, which is a layer that is able to open up an ARC map. And we'll click Save. And the other one we'll need is rate of spread. So NT ROS. Click Save. And then fire line intensity, NT FLI, and crown fire activity. I think, let's double check. Yep, crown fire activity. And save. Now, if you just did the fire behavior run without doing any inputs for the MTT, then you won't have these outputs. This is something that was automatically selected when I turned on some of the stuff that was going on with the MTT, so don't be concerned if you don't have these. We're not going to be using them anyway. Now, because I was not able to run that MTT, I am going to need the other files here that are referenced. So I need my burn probability file and my fire size list. If you weren't able to get that to run either, then you will need to get that information from bblearn. For me, I have it on a thumb drive, so you will do the same thing, just to navigate to the file where you saved that information off of bblearn. And so here's my NT files. I'm going to copy those and I'm going to paste them into my outputs folder that I created. So now I should have 6 files that are labeled NT, and those are going to be all the ones that you'll need for the no treatment. You're going to follow the same procedure for the other 2 landscape files. So you can either delete this run, or you can create a new run here, so that just will be a new run. So you can either start from a new page, or you can start again from here, labeling this slopes completed 2014, finding your fuel moisture file in your inputs folder, changing this to 6, 230, apply, fireline intensity, rate of spread, flame length, current fire activity, and I'm not even going to bother with the minimum travel time for now, and I will click apply and launch basic fire behavior. And that's complete. Close. And now I can see I have my slopes output here. So now I would go through the same process of saving each of these files, and I would save these files as SL #14 flame length. Well, I need to save this in the outputs folder. I would save that there. So go and complete saving all of these, and then do your final run with your slopes target areas, and then make sure all the information that you weren't able to run, if that's the case, is in this outputs folder. When you're done, your outputs folder should look like this, where you have the same number of outputs for each of the different treatment types. So double check that you have everything. You might have forgotten to save one. And with this information, you are now ready to move on to the next step, which is to analyze the effects or effectiveness of the treatment alternatives. So to our ARC Fuels directions, below this designing fuel treatment alternatives, we're going to be clicking analyze the effectiveness of treatment alternatives, and looking at the different steps that are outlined here, we're going to be post-processing our flam map behave outputs first, and we're not going to be doing number 2, but then we will use the post-processing that we've completed to complete these 3 steps. So let's see what we need to do for post-processing. So we'll go here, we'll click do the exercise, and we'll see that the first step we need to do is go back to ARC and to batch convert our ASCII files into rasters. So ASCII files are something that, although you can see them visually, you can't do any manipulation with them in ARC. So those need to be converted into rasters. So we're going to go to ARC. Let me look a little bit more in my directions. So before we can start to convert these, we're going to need to add a layer to this ARC project so that we can be given a projection. So I'm going to add some data. And I'm going to add the polygon that I created for the burns that occurred in the last several years. So that was in my Grand Canyon data folder, in my Grand Canyon fire data, fire history, and I'm going to select my North Rim fires here. So this serves the purpose of one, defining those areas, and so I can reference them when I'm looking at my output, but then also it'll give this project a spatial reference. So then we'll go to Tools and Batch Convert ASCII to Raster. And our source folder is going to be our project folder in the outputs. And looking at our directions here, we can see that the first file that we're going to convert is the Crown Fire activity file. And in this example, in ArcFuels, they have several more files than we do, so we'll only have 3. So I'll find all those CFA files and click Select File, and Select File, Select File. Make sure this is selected as integer, and the spatial reference is here, and if we had not added any layer, then there would be no spatial reference as an option here. And so then let's check our directions. And our target folder is also going to be the outputs folder. So I'm going to copy this path into this area and then click Convert. So those files were successfully converted. Click OK. And back to the directions. So now we're going to move forward with converting the rest of our files. And the reason that we converted the Crown Fire activity first is that that one was in the integer format, and these other files are going to be in the floating point format. Now in these directions it says to exclude the no treatment flame length. We're going to keep that in there for now and just run it all together. So we'll go back to our batch, and other than the text files, we're going to be moving everything over. So now you should have nothing left but the text files in the files in the folder, and that matches with what we see on the tutorial here. And this time we will select floating point, and our spatial reference is correct, outputs folder is correct, and we'll click Convert. So our files were successfully converted. Click OK. And back to the directions for our final step. So now we're going to batch convert the fire size list into shape files. So the fire size list is a text file, and it needs to be converted into that shape file so we can actually see it. So we'll go to close this, risk, and batch convert fire size list. We'll find our folder, which I actually might have pasted still, or copied still. Yep, good, that was easy. And so I'll go to select these 3 files and check my directions. So we'll keep it as FlamApp5 input source and target folder, outputs folder, and we'll make sure it's the right projection. And before I click convert, I always like to double check. Now we can click convert. And our files were created successfully. And we can close this, make my arc bigger. So now we have all kinds of files that we just made. I'm going to use my control button and click my minus sign and control and click the check. And that's going to turn them all off. And then I can turn them on when I want to look at them individually. That'll save a little bit of time in loading them each. So I'll go back to my arc fields direction. So now that we have all of these added, and we can start to do some manipulation. So we're not going to be doing this first step of summarizing fire behavior, so we'll skip that. And we'll move on to mapping burn probability and change in burn probability across the landscape. So we're going to do the exercise here. So according to this, we're going to be visually comparing the burn probabilities across our 3 different treatments. And to do that, we're going to need to make sure that they're displayed the same way. So the first thing we'll do is we'll look at the values that are in each of those layers and see which one has the widest range of values. So I'm going to do some sorting here. I'm going to slide my burn probability layers all to the same spot. And then I will expand them each and look at their ranges. So it looks like, one, we have pretty low burn probabilities, and that the largest range is with this SL14BP, so the treatment that was done in 2014. So the next part of this, I'm going to minimize this over here to give me a little more space to look at the directions. So the next step here is to left click on the existing color ramp and select a new color ramp. So left click on the one with the largest spread, and I clicked right on the color ramp there, and I'm going to choose this one that goes from more the color of the rainbow there, and click OK. I'll stick this on so we can actually see it. And so then to adjust the range of the other two, we'll need to go to right click on here and properties and stretched, and we're going to import the symbology from a different layer. So we're going to use the one from SL14BP. Click OK, and that will match the color and it will match the distribution, but it will show the values as different since there's different values there. Click OK. And so you can see this slight difference in burn probability from one to the next. So that's with target areas, and we'll do the same thing here. So right click and properties and import again from that original file SL14BP. Click OK and OK, and I'll turn that on, and now we should be able to see a pretty good change between each of these. So there's a little bit of change between the no treatment and the treatment that occurred in 2014, and then pretty significant change between the treatment that is proposed and the one that occurred in 2014. So that's interesting to note. Now, in order to really visually get an idea about this, it's best to compare these side to side, which is something that you would need to do if you were going to be presenting this to somebody. So we're going to go through the process of doing that right now. Notice that when you go to this layout view, it shows you what we see on the active screen. And when you go to Insert Data Frame, you now have 2 frames of reference. So what we're going to do is make 3 data frames, and to each data frame we will have one of these burn probabilities, and then we'll have a table of contents. So now I'm going to add one more data frame. Oops. Insert data frame. And now I have my 3 data frames. And in each of these data frames I need to have one of these BP layers selected. So I'm just going to take this and drag it to this other data frame. And I'll take this one, NT, and drag it to the 3rd one. And now you can see that I have these ones remain. That just was a copy essentially. So I'm going to just turn them off, and I'll turn this one on. I'll minimize these to save space. And now I have, actually I'm going to drag this data frame above here. Then they'll be a little bit more consolidated. There we go. So now I have my 3 data frames, and what I want to do now is arrange this page because it's pretty messy and I have no idea what's going on if I were to show this to anybody. So the first thing I want to do is change the orientation. So I'm going to go to File and Page and Print Setup and click Landscape. Click OK. So that makes the space a little bit more reasonable. And now notice that I've got a couple different extents here. So this one is kind of zoomed in and these other 2 are zoomed out. And so notice that when I click on one, it activates that layer. So if I've clicked here and this becomes bold, and if I click down here, then this data frame becomes bold, and over here this data frame becomes bold. That'll be important for you to help identify which layer is which here. So I'm going to click here, that activates it, and that means that all these tools, these zoom tools, they apply to that. So I'm going to zoom out a little bit and try and get roughly the same size. And I'm going to square this out. And now I'm actually going to zoom back in, pull this out a little bit. So now I've got roughly the same size, and so I just need to decide how I want these displayed. And I might actually change my mind here and bring this back to portrait. Just depends on what you want to do aesthetically. You actually have free reign on how you want to arrange yours. So now I want to make sure that they're in the right order, and that'll add my map information. So we've got target areas here, and we have no treatment here, so I want to move that one up. And then this is our 2014 slopes. We'll move that here. And you guys can spend a lot of time moving things around. I'm just going to leave it pretty simple for now. So I'm going to start by adding a title. And this is going to be the title for the whole page. So I'm going to call this So I'm going to call this North Rim Slopes Project, and click OK. And notice to get to that edit, I had to double click on this and went to an edit screen. And I'll move things down. Now again, I'm not making my map the most beautiful, so you guys can get creative. And now I'm going to insert some text boxes. So there's the text box down there, really small. And so I will double click on this text box, pull it out here, and change the text to say no treatment. Now changing the font size here is a little more challenging, so I can't just change the font here, I actually have to change the size. And so this is a little bit of just a guessing game to see what size it might take. So I'm going to change the height, actually. I'll change the height to 3.3552 and just see what happens there. So that actually looks about right for my size, so you can kind of mess around with that. Notice that back here on the text tab it did change the font size. There's other ways to do this with some HTML stuff, but this is a way that works for now. So click OK. And move this up, I'll just move it here, and then I'll create another text box and do the same thing. And this also let me move this off of here again just so that I make sure I have the right one selected. Change this to 3 and then apply, and in the text I want it to say slopes completed 2014. Click OK. And then another text box, and again move that off, and we'll call this one slopes target areas, and change the size or position to height of 3. Click OK. Notice that by changing the width, that would have just that wouldn't have made much of a difference, or it'd be hard to be consistent since they all have different amounts of writing in them. And now we want to add a scale bar. Now scale bar might be a little tricky because theoretically each of these are zoomed somewhat to a different extent, so that's why zooming them to as close as possible the same is going to be your best bet, because you're not going to add a scale bar for each one of the data frames. You're just going to add it for one, and you want to make sure that it applies to the others. So we'll do insert scale bar and pick something simple. So this can go down here, and you can change how long or wide this is, and when you change how big it is, it changes the values here, and you can, if you want it to be short, then you might take out some of those breaks. So you could double click on this and change the number of subdivisions and divisions. You can change the units that it's in, depending on what your purpose is. So there's a couple different options there. Again, size and position. So you can manipulate that however you'd like. And then we'll also insert a north arrow. Put that over there. And the last thing we'll enter is our legend. And so we're going to use just one map layer, because again, theoretically our legend should all be the same. And the title, would be legend. We can come back here to add a border if we want to, or background or drop shadow. And just more formatting information. So now we have our legend. And most of the time when we create a legend, there's some values that we don't really need. For example, we actually don't need it to say NTBP. And so we're just going to go here and clear that off for the time being so that we lose that in our legend. So to get, if you want to do non-aspect ratio changing, you'll have to go double click and then actually go into the size and position. You can change width and things here. If you, in the way that you are formatting your legend, want to make your legend over things here, then you might want to put a background color on it. So for now, this is what you are going for, and when you have completed your map in the way that you want it to look, you would then export your map into your lesson folder and submit that on BB Learn. So if you haven't already done so, now would probably be a good time to save this ArcMap project. I'm going to go to my Lesson 5 folder and save this as Lesson 5. Step 2 in this part of the exercise, so I'm going to scroll down here. We were in mapping burn probability. And step 2, subtract the treatment from the no treatment alternative raster to create change maps. So to do this, we're going to be using some of the spatial analyst tools in the ARC toolbar. And so we will go to our project, go back to this data view, and I'm going to, since we're done using these, I'm just going to drag them down to the bottom here. And to make sure that this is the active layer, I'm going to right click and activate, so that now it's bolded, as you can see. And we do still have these other layers here, so that's good. So I'm going to go to ARC Toolbox and go to Spatial Analyst, and then Math, and Minus. And I'll check my directions. So we're going to have our input raster be no treatment burn probability, and our input raster or constant value is going to be the second or the first treatment that's already been completed, and then we'll create an output raster. Input value here of no treatment and our constant one is going to be this slopes 2014, and we will designate a folder here for our work, and we're going to go with our outputs folder here. Mine landed on the right one. Oh no, it landed on lesson 4. So I will go so I will go to lesson 5 outputs, and I will label this SL14 BP and change. And I will label this NT for no treatment, and then also SL14, So that tells me it's no treatment and SL14, and it's the burn probability. And then click Save, and OK. So our minus is now complete. I'll go back to my table of contents, and instead of following the directions here in Arc Fuels with making a classified visualization, I'm actually going to use the same technique that we had done in the previous step for making these the next two files the same color ramp. So the next step I'm going to do is make my other file. So I'm going to go back to Arc, and in my toolbox, go to Math and Minus, and this time I'm going to pick my no treatment again for BP, and I'm going to subtract that from my slopes target areas. And choose a location for that, and name it NT SLTA, so no treatment, and then slopes target areas, and BP, and click Save, and then click OK. And I already have that created, so I'll just close this out. So now you'll have both of these in your table of contents, and so just like we did before, we're going to pick the one with the broader range, and we'll use that one to base off for the way that it stretches those values. So we'll look here, this one goes from 0.0075, which is a higher number here, and then this goes from negative 0.007 and negative 0.0145. So this is going to be the broader range here, so it goes higher and lower. So following the directions back in Arc Fuels for how to do that, we're going to left click here, and choose a color ramp. I'm going to match the color ramp that was chosen from the Arc Fuels exercise, so I'm going to use this blue-green mixture, and click OK. So now let's go and make our adjustments here, and we will do our properties for this one, and we're going to import from SL14BP. Click OK, and OK. So now we can visually compare these two and see how they've changed. So let's look quickly at the numbers and think about what they might mean. To help us do this, I think it'll be useful to add our slopes completed and our slopes target area files so that we can see where these changes have taken place. So I'll add my slopes completed, and I will add target areas 2015 in the slopes planning folder, and I'll make both of these hollow, and one of them I'll make purple, and one I will make red. Alright, so we've got high values, which means that there was a higher amount of burn probability change, so there's a higher likelihood. So to think about this, we have to kind of break down what we actually did here. So we took our burn probability maps and subtracted them. So just looking at the burn probability map, we have a high burn probability and a low burn probability. So the low burn probability is always going to be 0, since that's the least that could happen, and a high burn probability. So there's areas here, just look at these. There's areas here that are more likely to burn, and there's areas here that are less likely to burn. And when we subtract 2 of these burn probability layers, then we get a difference. And the areas where there's a difference, a positive value, that means that's an area where the burn probability decreased. So if you think about starting out with a high number and then subtracting a lower number, you will get a positive value here. If you start out with a lower number and you end with a higher number, then you will end up with a negative number. So what you can see as you look across this landscape is you see that there are some areas, these green areas, that are lower, so they might even be in the negative values, and we'll look at this when we look at the spread of values. So why would burn probability have increased effectively in some of these areas? This is something that is actually relatively common when you change your fuel models, especially to fuel models that have a higher component of flashier fuel. So if you went from a timber fuel model to a fuel model that contained a lot of grass, then you're going to have a higher burn probability. So that in and of itself does not mean that you had an ineffective fuel treatment. It just means that you changed the type of fire that's on the ground. So then burn probability increasing isn't necessarily a bad thing, and so that's why it's really important to accompany with some analysis of flame length, because if you have a reduction in your flame length but an increase in your burn probability, then you have a better understanding that you just changed the type of fire that was there to a lower severity type of fire. So now, because we want to visually compare these two maps, we're again going to create a map in the layout view. So we'll go to our layout view here, and I've already started on this a little bit, but it needs a lot of work. So the first thing I'm going to do is I'm going to set up my data frames. So I'm going to have my data frame here. This is something I was working on before. I'm going to just remove this, and you'll have your previous data frames, and so you can delete the third data frame. You no longer need that. And I'm going to pull down these 3 layers, highlight them all using Control, and slide them down and put them in the new data frame. And now you have some similarities there. Remove this one. And so you can start to do your visual comparison. And so I had switched my view to landscape. Again, you can do whatever you'd like there, and make sure that turn this one off so that it's not showing up. And I will re-add my legend. And so for the legend, I actually want it to pull up just one of the ramps since they're the same, so that's fine. And I will click Next. Title's okay. And here's the legend I get. So there's a couple of things that would definitely be more useful to be called if I were to be presenting this to somebody. And so I'm going to delete values here. And it goes away over there. And I'm going to change the name of this layer to something that's a little bit more understandable. So we'll just call this change in burn probability. And I'm going to just add a date here. And I think I'm going to change the formatting on this a little bit and make it just a little skinnier so it doesn't make it so hard to see. And we'll have to do that on both of them. Then you can see underneath them a little bit better. So continue to play around with the formatting here, and then you will again be exporting this map and saving it and submitting that on BBLearn. So I'm going to take a second to save my project, just in case something happens. And now I'm going to go back to Arc Fuels and check out the next step. So next we're going to be calculating area by flame length category and fire type. And this is going to be a really important thing to produce to compare, especially with our burn probabilities. So I'll click do the exercise. And so step number 1 is going to be to use the spatial analyst tools and to reclass some of these flame length layers. I'm going to minimize this so I can see a little bit more. So we'll go to our ARC project, back to our main slide here, and I'm going to turn some of these layers off and shrink them up again. And I'm going to go to Arc Toolbox and Spatial Analyst and Reclass and Reclassify. And we'll go to our first flame length file here. So we've got slopes 14 flame length, and value is our reclass field, and we'll click classify. And to start, we'll do equal interval, and we need 4 classes. And now I'm going to change this to manual, so it stays as the 4 classes. Now I can adjust our numbers here. And so we're going to put this as 4, this one as 8, this one as 11, so this is in feet. And we'll leave this highest one the same, and click OK. And for outputs, I'm going to navigate to my outputs folder, and I'm going to name this SL14 flame length, and I'm going to add an HC at the bottom. And the HC means hauling chart, and that means that this flame length has been reclassified with values from the hauling chart, which is this classification of flame length, the 4, 8, and 11 feet, that kind of helps us determine what kind of attack can be done on the fire if it has that kind of flame length. So we'll click Save there, and then we're going to set up an environments here. We don't need to classify our flame length across the whole area, and so we're going to go to raster analysis, and we're just going to be doing an analysis of flame length in the completed areas in 2014. Click OK, and OK again. And so we've had a successful reclassification. So now we'll go back to our Arc Toolbox, click Reclassify again, and I'm going to go next to my target area's flame length, and I'm going to click Classify again, and equal interval 4, manual, change these numbers again to 4, 8, 11, and leave that the same. Click OK, and change my output location. Call this SLTA flame length HC. Save. Now here on environments, I'm going to change this to the target areas. So it's just going to calculate the flame length for the target areas. And click OK. And OK. So again, successfully completed. And don't worry about the colors here, that's just randomly assigned colors. So now we're going to go to our no treatment. Now for no treatment, we're going to need to do 2 no treatment flame lengths. We're going to need to know the flame length in the slopes completed and the flame lengths in the target areas, and then we'll compare each of those files, the flame length of 2014 and target areas, to their respective no treatment. So I'm going to go again to reclassify, and I'm going to select my no treatment flame length, and there are a couple of error messages that pop up when you're doing this, but I haven't found them to interfere with the values that we get. So unique values cannot be obtained from raster. Just click OK. We'll go through the same process here, equal interval, for manual, change this to 4, 8, 11, and leave that one the same. Click OK. And for our name, we're going to want this to be, I've named this already, so we're going to want this to be no treatment SL HC, and then label it 1-4. So that is going to tell us that this is from the no treatment over the area of the 2014 treatment area. So put that in there, and then in environments you're going to select the slopes 2014 as an area, and you'd click OK. And as that processes, you will end up with this layer here. So that's the no treatment area, and you can see that it matches up to the 2014. So now we will do that same calculation again, except this time with the target areas. So again, using our no treatment flame length, classify, equal interval, 4, manual, 8, 4, 8, there we go, and 11. And you can see we have some pretty crazy numbers here. I'm just going to bring this down to the scale of the previous one, so I'll go to 390 for that, and click OK, and label this in my outputs folder NT underscore FL HC for hauling chart and TA for target areas. Click Save, and on environments, change the mask to target areas, click OK, and OK. And you'll notice with both of those that you end up with an exclamation point here, and that just says that there are some unrecognizable values in the higher end, and we're just going to accept that for now. And so we'll look at our tables here, and again we have these 4 different classifications, and it gives you the number of pixels in each of those classifications. So now we need to add a little bit more information to each of these attribute tables. So I'm just going to start with my first one here, right click, open attribute table, and I'm going to add a new column. So from my table options, go to add field, and I'm going to label this area underscore acres, or AC, and I'm going to change this to long integer, and that has to do with how long the values are that are going to be in that field. And I'll click OK. And now I'm going to calculate the area for each of these classifications of flame length. So we have done this before. We'll go through this again. So I'm going to right click here and select field calculator, and yes. And for my count, so the number of pixels that I have, so each pixel we know is 30 by 30 meters, and with the math that we figured out before, we're going to multiply that by 2.0002, and that'll give us the number of acres. So that many 2.002 pixels in an acre, and so that will give us the number of acres. And click OK. So now we have our acres here, so we'll do that for our other files as well. So now that you have your 4 tables calculated for area, you're going to be making a table to compare the values. So in following the pattern of the table here, you're going to create a table in Excel, and I'll just give an example here. So you'd have your flame length, and always include your units, so that's in feet, and then you'd have your no treatment, and that's acres. And no treatment, this is going to be for, actually I will do a label on top of that. So this is going to be your slopes 2014, and this is going to be your no treatment, again acres, and this will be your slopes. Actually, I'm going to leave that name off, so we'll just have this be slopes here, and I'm going to make a broader category here. I'll make this bigger. So I'll merge this and call this completed 2014, and merge this and call it target areas. But I will add my units. And I'm going to extend, actually I'm going to wrap the text here. I can extend this out, and then you'll go here, so you have your classifications, and they're going to be the same as the ones that are listed here in the ArcFuels tutorial. And then you're going to get those numbers populated from the numbers that you have here in the table. So now I'll move on to step 2, which is to calculate the area in Crown Fire activity classes for all 3 treatment alternatives. So Crown Fire activity is a pretty important indicator of that fire behavior. And so to start, we're going to be using the Extract by Mask tool in the Spatial Analyst tools, so that we can clip the Crown Fire activity layers into the areas that they're representing that treatment for. Since again, we don't really need to compare it across the landscape, we are just comparing in those treatments. One thing just as a side note is that these fire behavior calculations, they're done on a pixel by pixel basis, and so they don't relate to the thing that's next to them. That's why it doesn't make a whole lot of sense to compare any of the information that's outside of the treatment area. So to begin, we will go to our arc, close this out, back to Arc Toolbox, and we'll go to Extraction and Extract by Mask, and oops, I should have done right click here, and we'll do a batch. Now, unlike the tutorial ArcFuels, we'll just be doing 2. We're going to be doing the no treatment and then one of the consecutive treatments, either the target areas or the completed. So our input raster is going to be we're looking for things in the conversion results folder, so no treatment Crown Fire activity here, and this is going to be this is going to be the slopes 2014 Crown Fire activity, and the input raster or feature for clipping is going to be the completed and completed. And actually, it looks like we can choose different ones. So I'm going to go ahead and add another one here. And so we'll add our no treatment again. So no treatment Crown Fire activity. And this time, the input feature to mask off of is going to be our target areas. And then adding another one, we'll do the SL target areas crown fire activity. And again, the mask for that is going to be these target areas. And then we'll need to select our output raster. And we're going to navigate again to our output folder, which is getting quite full. And I'll label this NT CFA and then C. Click Save and OK. I'm going to expand this a little bit so we can see all of those files just to make sure that I'm getting them in the right spot. And here we have, we'll label this one SL14CFA C for clipped. Click OK. And here we'll have NT CFA. And again, I just remembered we needed to distinguish between the one that's clipped for the 2014 completed and the target areas. So this one will be our target areas. So we'll say TA and C for clipped. And I'll go back and change this one to 14. And then this one will be SL TA CFA for crown fire activity and C for clipped. Click Save. OK. And we'll click the OK button to start the process. So our extract by mask was complete. And we'll go to our table of contents. So now we have 1, 2, 3, 4 new files there. And so just going to the ARC Fuels tutorial, you can see that we're going to again make a column in each of those for area. And then we will create a table. And so there's 3 classes: surface fire, passive crown fire, and active crown fire. And fill in the number of pixels in each of those categories in each of our treatment types. So right click, open attribute, add field, so once that's complete, then referring to our ARC Fuels tutorial, we will again be making a table with those values inputted. And so again, going to your booklet here, you will have your crown fire activity, and I'm just going to copy these cells here and paste them. And now I'm going to enter that information. So it will have our crown fire activity, number of pixels with each of that crown fire level inputted for both the no treatment and the slopes completed and the slopes target areas. So now you can, once this is all filled in, then you can take a screen capture of your completed tables and you can submit that for your question on bblearn. So also included in the questions is some analysis of what these numbers mean and how they might be interpreted as far as the effectiveness of this fuel treatment. So for the last part of this exercise, you can perform the averaging fire size list inside and outside of treatments as extra credit.